Hello everyone, I'm Yue from Shenzhen Institute of Computing Sciences. The paper is HowSim, a general and effective similarity measure on heterogeneous information networks. This is a joint work with Hong Kong UST and the WeChat Group. Here is the outline of the presentation. Currently, many information systems can be modeled as graphs, such as social networks, biological network, and collaboration network. Besides, many real-world graphs are heterogeneous, which have different types of nodes and edges. Here is an example of bibliographic network, which has node types such as author, paper, venue, and the links indicates an author write a paper or a paper is published in venue. Here is an example of IMDb network, which has node types of movie, actor, and producer. The links indicate a producer makes a movie or an actor acts in a movie. Next, we introduce our motivation. We study the problem of similarity search. The motivation is to find similar objects over an HIN. For example, given a bibliographic network, a user may want to find which researchers are similar to Professor Han. Besides, given an IMDb network, a user may want to find similar actors to Tom Cruise, or similar movies to Titanic. Similarity search has many applications such as link prediction, personalized recommendation, and clustering. Currently, many methods use MeetPath in similarity search. MeetPath is a sequence of node classes and edge types along the path between two nodes. Here is an example of bibliographic network. The MeetPath APA indicates two authors have collaborated on the same paper, and a path instance following APA is x1, p1, x2. There's also other MeetPaths. HowSim is a MeetPath-based similarity measure which is proposed in VLDB 2011. Specifically, given a symmetric MeetPath and nodes A and B, it first counts the number of path instances between A and B. If there is a lot of such path instances, then A and B is similar. Besides, HowSim also counts the path instance between node A to itself and node B to itself. These two terms are used to normalize the HowSim score. HowSim is another path-based, a metapath-based similarity measure. It is proposed in TKDE 2014. HowSim recursively aggregates the similarity along the metapath. Given a metapath with the relation R1 to RL, the similarity of nodes A and B depends on the neighbors of A and B under the relation R1 and RL. So, this is a recursive definition. When the length of the metapath is odd, HowSim creates a dummy relation in the middle to make this equation valid. Even though metapath-based methods are popular, they suffer from generality and usability. First, when metapaths can only capture one particular semantic meaning connecting two nodes, thus it fails to aggregate all possible semantic information. A user can provide multiple metapaths and can combine the similarity results. However, it is hard to adjust the weights because it is non-trivial to decide which metapath is better than the other. Besides, evaluating different types of nodes requires different metapaths. For example, if we want to evaluate the similarities of papers, then the candidate metapaths are PAP, PVP, PA, PVP, and so on. If we change our query to find similar authors, the candidate metapath is APA or APVPA. So, metapath-based methods leads to plenty workload of metapath enumeration and selection. Another way to evaluate similarity over an HN is to treat it as a homogeneous graph, and then use an existing structural similarity measure. SimRank is a popular similarity measure, which has attracted a lot of research attention. The intuition of SimRank is two nodes are similar if they are linked by similar nodes. Here is a definition. When U equals to V, the similarity is 1, otherwise the similarity is aggregate from their neighbors. Here, C is the decay factor, which is between 0 and 1. Personalized PageRank is another popular similarity measure. The intuition is node T is similar to node S if T is similar to S neighbors. Here is the definition. It is still recursive. It only iterates over S out neighbor. So PPR is not symmetric. The issue of using structural similarity on heterogeneous graphs is that the semantic information is ignored. Next, we introduce our method. Our goal is to define a similarity measure for HIN which can combine the structural information and semantic information. And the measure can aggregate multiple semantic meanings and it is easy to use. Our basic idea is to extend SimRank to HIN and utilize the network schema of an HIN. The network schema is a meta template for an HIN. It is bidirectional graph. The vertices are the types of nodes, and the edges of the schema is the different relation types. Here is an example of network schema on bibliographic data. Now we define our HowSim method. The intuition is HowSim is first, similarity are defined on the same types of nodes, and the two objects are similar if they have similar neighbors. Third, an object has the similarity of 1 with itself. Next, we define the decay function. A decay function maps each type of relation to real number between 0 and 1, and it has a constraint that for each type of nodes, the summation of outgoing relation is smaller than 1. The decay function can also be represented by a weighted graph, whose structure is the same as the network schema, and the weight on each edge indicates the decay value. Now we give the definition of HowSim. Suppose nodes A and B are of type A, and RA is the set of outgoing relations of type A on network schema. When A is equal to B, the HowSim score is 1, otherwise HowSim iterates over relations in RA and aggregates the similarity of neighbors and this relation, scaled by the decay function, which can be viewed as the importance of this relation in similarity aggregation. The decay function actually describes how HowSim scores are aggregated from different types of nodes and relations. Here is an example of decay function defined on previous bibliographic network. If we want to compute the similarity of two papers, 20% come from the average similarity of venues they published in. 10% comes from the average similarity of author who writes them. 30% come from the average similarity of paper they cite, and 20% comes from similarity of papers which cite them. If we want to compute similarity of two venues, 15% comes from the average similarity of papers they publish. We say HowSim is a general similarity measure due to the following reasons. First, SimRank and its variants are just special cases under HowSim model, since they are just different initializations of the decay graph. Second, once given the decay graph, all similarity scores in all domains in an HIN are determinate, without requiring users to provide any additional metapath information. Third, HowSim can combine the semantic meaning of different paths due to its recursive definition. Besides, we prove HowSim is normalized self-maximum, and the solution of HowSim is unique. Like SimRank, the all-pairs HowSim scout can be computed iteratively, and the result converges to the ground truth. Besides, the optimization techniques for SimRank can be used to accelerate HowSim computation, such as selecting candidate pairs and partial sum. Next, we introduce the experimental results. In the experiments, we use 5 real-world datasets. IMDb is an HIN about information of movies. DBIS is a collaboration network of database community. Last.fm contains social networking and tagging and musician artists. Delicious bookmarks contain the social networking, bookmarking, and tagging information. Amazon is a shopping platform. We compare HowSim with other similarity measures. PPR and weighted PPR and SimRank are popular measures on homogeneous graph. PathSim, HenrySim, and NSimGram are designed for heterogeneous graphs. We perform the case study to compare the structural similarity, that is, weighted PPR. We use the delicious bookmark dataset and query similar bookmarks of websites. The query is about popular JavaScript talks. We can see the results of HowSim are all about front-end techniques. However, weighted PPR returns some unrelated web pages such as TED Talks and Python programming. We also change the query to tag and query the tag iPhone development. Here is the results. We can see the results of weighted PPR return some unrelated tags, such as GitHub or open source. We next test the flexibility of decay graphs to aggregate similarity in different aspects. Given the network schema of IMDb, we query similar movies. We define 3 decay graphs. The first one focuses more on the similarity of directors. The second one focuses more on the similarity of actors. And the third one focuses more on the similarity of genres. Then we find movies that is similar to Titanic. We can find the decay function returns a movie that is directed by the James Cameron in the first results. For the second results, the results are most from actor Leonardo and the actress Kate. For the third result, the movies are belong to the romantic drama, which is similar to Titanic. We test the quality of clustering of different measures. We use the companions to evaluate the quality. We can find how HowSim achieves the highest companions. We compare different measures with respect to the quality of link prediction. We can also find how HowSim has the highest precision with different k, where k means the number of edges which are removed. We compare the computation costs of naive iteration and optimized iteration. We can find they both have an accuracy guarantee, and the optimized iteration is faster than the naive one. Next, we summarize our paper. We propose a general and metapath-free similarity measure HowSim by proposing the concept of decay graph to extend SimRank to HIN. We study the properties of HowSim in depth and show it is symmetric, non-negative, normalized, and self-maximum. We introduce iterative methods to compute HowSim, which has accuracy guarantee, and we perform extensive experiments to show the effectiveness and efficiency of our method. That's all. Thanks.